In this video, we are going to solve a system of linear equations using the substitution strategy. So previously, we learned how to solve a system of linear equations using the graphing strategy. And when we used that graphing strategy, what we did was we graphed the two lines on the graph and we looked for a point of intersection. And for all of the problems we've done previously, they would typically cross at a really nice coordinate point. However, if we get an example like this, so see how these two lines aren't crossing at a nice point, it's difficult to determine that point. So it's difficult to determine that point accurately. So essentially what we need are other strategies that will allow us to find what that point is, even if it's not a nice point. And that's what we're going to start to cover in today's video. And we're going to use a strategy called substitution in order to do this. So the substitution strategy is an algebraic method that is used to solve a system of linear equations. And it's typically used when we can easily rewrite one equation for one variable alone. And typically this means that we can do it in one single step. So what I mean by this is if we look at these two examples down below, what we'll notice in this first example is we have two equations with the same variables, so we know it's a system of equations. And if I look at the four variables, so here I have x in the first equation, y in the first equation, x in the second equation, and y in the second equation. What I notice is that I could easily get this x value right here alone if I just subtract 2y from each side. So I can get x by itself in one step, and this will say x is equal to 7 plus a negative 2y. So when I can get one of those equations written in terms of one variable by itself in one step, this is when substitution is a great strategy. If we look over at the next example, so here we have equation 1 and equation 2, what we'll notice is again we have four variables. So we have x in the first equation, y in the first equation, x in the second equation, and y in the second equation. And what I notice here is if I look at the four variables, I could get this y in the first equation by itself really quickly in one single step if I were to add 2x to each side. So we would have y equals 3 plus 2x. So if you notice that you can rewrite one of those equations for one variable alone in one single step, that is a situation where substitution is going to be a good method of choice. So these are the 5 steps we're going to follow when we solve a system using the substitution strategy. And I'm not going to break them down right now, but I just want you to look through them and notice that the first thing we're going to do is we're going to solve for one variable alone. So that talks about the previous slide where you can easily get x or y alone in one of the equations. Then what we're going to do is we're going to box it up and we're going to substitute it into the other equation. We'll then have an equation with one variable so we can solve for the first variable. And now that we know the first variable value, we can substitute it into the original equations, find the other, and then we'll write our final answer as an ordered pair. So now we're going to walk through those same steps. Our first step is we need to solve for one of the equations for x or y alone. And when I look here, what I notice is I actually have two options. I could either solve for this y alone in one single step by adding 3x to each side, or this x alone by subtracting 2y from each side. And it ultimately doesn't matter, we just need to commit to one. So for this particular problem, I'm going to commit to the y. So we're going to get that y value that I have circled by itself, and we do so by adding 3x to each side. So essentially what I've done is I've taken that first equation and I've rewritten it for y equals 2 plus 3x. And then what I note here is that y is equal to 2 plus 3x. And remember, an equal sign means that they are the same value. So what this means here is that y and 2 plus 3x regardless of what their variable values are, y and 2 plus 3x have the exact same value. So what I can do is I can actually replace y with its equivalent, which is 2 plus 3x. They are the same thing. So what I'm going to do here is I'm going to box it up and say, well, y and 2 plus 3x are the same thing. And I'm going to substitute it in for y in this second equation. So I'm going to rewrite the second equation, and as I do that, I'm going to replace y with what it's equivalent to, which is 2 plus 3x. So here we have x plus 2. I'm replacing y with something it's equivalent to, which in this case I notice is 2 plus 3x. And notice I'm putting it in parentheses there to say this is all going in place of y. So notice I have this exact same second equation here. All I've done is replace this y value with something that it's equivalent to, which is 2 plus 3x. But what's really nice here and why we can use substitution is if we look at this equation now, we'll notice that it only consists of an x variable. So what we now need to do is we need to solve this equation for x. And the first thing I notice is that it contains parentheses. So I'm going to start by distributing the 2 to the numbers inside. So I have x plus 4 plus 6x is equal to 11. I then notice that I have like terms on the same side of the equation. So I have 7x plus 4 is equal to 11. I then want to get the x alone, so I subtract 4 from each side, and I end up with 7x is equal to 7. Divide both sides by 7, and I find that x is equal to 1. Now remember, when we're solving a system, we are finding a point of intersection. So essentially what I found here, when I find a point of intersection, when I find my x value, in my ordered pair, I have found my x value is 1. And now what I need to find is the y value that pairs with it. So what I'm going to do is I'm going to take that x value and I'm going to substitute it back into one of these two original equations, because those two original equations have the same x and y point where they are crossing. So what I can do is I can replace x in one of those equations with 1 and find the corresponding y value. So say I pick the first equation here. So I have negative 3x plus y equals 2. So here it would be negative 3. I know x is 1 plus y is equal to 2. So I have negative 3 plus y equals 2. I need to get y alone, so I add 3 to each side, and I find y is equal to 5. Now, I've had some students in the past who didn't necessarily believe me that you could pick either equation. So we're going to try this second one just to make sure we get the same y value, the same point where they cross. So here we have x plus 2y equals 11. So here I have 1 in place of the x because that's what x is equal to. Plus 2y equals 11. Subtract 1 from each side. We get 2y is equal to 10, divide by 2, and we find y is equal to 5. So notice that regardless of the equation we use, we get the same y value because this is the point where these two lines cross. These two lines cross when x is 1 and y is 5. So again, I'm looking to use substitution here, and if I look at my two starting equations, what I notice is that this y value here would be very, very, very easy to get alone. And this one might be easy to get alone. I would just have to deal with that negative 1 out in front. So I'm looking for variables that I can get alone in one step. And the easiest one is going to be the y value in that first equation. So I'm going to focus on getting y alone here by adding 4x to each side. So I end up with y is equal to a negative 4 plus 4x. And then what I'm going to do is I'm going to box it up, and I'm going to replace y in the other equation with what it's equivalent to, which is negative 4 plus 4x. So I'm going to replace this y here with its equivalent of -4 plus 4x. So now I go down to step 2 and I actually replace y in this second equation. So I have 3x minus, then in parentheses, -4 plus 4x, so that's all going in place of y, is equal to 2. And then from here I notice that I have a negative number in front of the parentheses, which is really a -1, so I'm going to utilize keep, change here. And then in order to solve for that first variable, I'm going to distribute that -1. So here I have 3x, -1 times -4 is plus 4, and then plus a -4x is equal to 2. And then from here I notice that I have like terms on the same side of the equation. So I have -1x plus 4 is equal to 2. Subtract 4 on each side, and I end up with -1x is equal to -2. Divide both sides by a -1, and I find that the x-coordinate in the point of intersection for these two lines is x is equal to 2. I then take this x equals 2 value, and I'm going to plug it back into one of these original equations here to find the corresponding y value. So I'm just going to pick the first equation. So here we have y minus 4 times 2 is equal to a -4. So I really have y minus 8 equals -4. Add 8 to each side, and I find y equals 4. So what I have essentially found here is that my point of intersection for these two linear equations occurs when x is 2 and y is 4. So now that we've looked at the substitution method, we're now going to look at situations where we can solve real-world problems utilizing substitution. So in this word problem it says many businesses pay website hosting companies to store and maintain files that make up their website. Company A charges a setup fee of $10 and then charges $21 per month, while Company B charges a setup fee of $0 but has a monthly fee of $22.45. Find when the two companies will cost the same. So that's ultimately what I am trying to find in this problem, is when they cost the same. So I'm noticing here that I have two unknown things in my problem. The first thing that's unknown is the when. It says find when. And I notice in here that I have months as an important piece of this. So X is going to stand for my number of months, because I need to find after how many months these two companies will in fact cost the same. Then from here, the other thing I don't know is the cost. I don't know what their cost is when they are the same. So my other variable is going to be cost. So here it says write two equations about the situation, one for each company. So I'm going to write an equation for company A, and I'm going to calculate cost. And so remember, my cost is calculated by a setup fee of $10 and $21 per month. So in order to calculate my cost, I know that up front I'm going to have to pay $10. But I only have to pay this $10 once. And after I pay this $10 once, I then have to pay 21.95 times the number of months that I've had that site. So that's going to be 21.95 times X, or you can just write 21.95X. So that's how my cost is calculated. So here I have $10 plus 21.95 times the number of months, and that is going to equal my cost. So here I've written a cost equation for company A. It's $10 as a flat fee plus $21.95 per month. Then I need to write an equation for company B. And company B calculates its cost a little bit differently. So here I have cost is equal to a $0 fee up front plus $22.45 per month. So now we have a cost equation for each company. And now we're going to utilize substitution in order to help us find when these two costs are the same. And remember, our first step in substitution is to get a variable alone. And if we look here, each equation actually already has a variable by itself. So just the way that we've written our equations, we've already set it up great for substitution as is. Now what we're going to do is we're going to substitute the value of one y in for another. So I'm going to take what y is equal to in this first equation. Remember, an equal sign means that each side has the same value. So y and 10 plus 2195x are both the exact same value. And what we're going to do is we're going to replace what y is equal to in for the other y value. Remember, we're trying to find when our costs are equal. So we're going to set the cost equation for each situation equal to each other. So now if we replace the y in the second equation with 10 plus 2195x, we'll have 10 plus 21.95x is equal to 0 plus 2245x. So we've now set those two cost equations equal. Now we want to solve for the value for x when this is occurring. So we subtract 2195x from each side. So I end up with 10 is equal to 0.50x. Divide both sides by 0.5. And I find that x is equal to 20. And remember, x is our number of months, so x is equal to 20 months. So what I found here is that at 20 months, both of these costs will be exactly the same. So now, if I want to find out what that cost is, what I can do is I can take the 20 months, I can substitute it back into either of these situations. So here, if I take the first situation and I want to find my cost at 20 months for each company, we have y equals 10 plus 21.95, and I'm going to replace x with 20 because that is what x is equal to when these two companies have the same cost. So now if I multiply 21.95 times 20, I end up with 439, and I then add $10 to it, and I find that the cost at 20 months for both of these companies is $449. So what I can conclude in this situation is that both A and B will cost $449 at 20 months. So this word problem states that the volleyball team is selling candy bars and bags of popcorn at the tournament this weekend. The volleyball team sells twice as many candy bars as bags of popcorn. They sold candy bars for $2 each and bags of popcorn for $3 each and sold a total of $175 worth of food. So we're trying to figure out how many candy bars we sold and how many bags of popcorn we sold. That's what we don't know in this situation. So what we're going to do is we're going to assign those to be variables. I'm going to assign x to be the number of candy bars and y to be the number of popcorns we sell. So that's what we're ultimately trying to find. Now, the one equation that I can see in here for sure is I can see that I have a cost equation. I can see that I sold candy bars for $2 each and bags of popcorn for $3 each. So in order to calculate my cost, it would be 2x plus 3y is equal to a total in sales of $175. So that equation in blue represents my cost situation. Now the second equation here is a little bit more difficult to see, and it actually stems from this detail in the second sentence, where it says that the volleyball team sells twice as many candy bars as bags of popcorn. So if I start to break this down, twice as many candy bars means that I sold more candy bars. That's the first thing I need to remember. And what I'm noticing is that with however many candy bars I sold, it is 2 times as many as the popcorn. Or, however many popcorns I sell, I'm going to take that, multiply it by 2 to make it twice as many, and that's how many candy bars I sold. Now, if I think about this in terms of variables, I notice that my popcorn is represented by y. So this is really y times 2 is equal to my number of candy bars, which is represented by x. So my second equation here is really going to be x is equal to, so my candy bars are equal to 2 times the amount of popcorn that I sell. So there now is my second equation. Now, part 2 says to solve this using substitution. And the reason that substitution is a great strategy here is because we already have a variable alone here in our second equation. So what we're going to do is we're going to take what x is equal to, and we're going to substitute it into the other equation in place of x, because x and 2 times y have the same value per that equal sign that is between them. So if I rewrite the first equation, I have 2 times, I'm going to replace x with 2y, plus the 3y that I'm leaving alone is equal to 175. So now what I can do is I have an equation with one variable. So now I can actually work through and solve this. Now notice that this parenthesis doesn't have a plus sign or a minus sign in it, so this is just really 2 times 2, which is 4 times y, plus the 3y. I notice that I have like terms on the same side of the equation, so I have 7y is equal to 175. Divide both sides by 7, and I find that y is equal to 25. Now I have to think about this for a second. Remember, y represents popcorn, so I sold 25 bags of popcorn. But remember, we have two values that we need to know from this problem. So if I think back and I realize, okay, I have 25 popcorns, let's use one of these original equations to help us determine how many candy bars we actually sold. Well, I notice this second equation is really easy. This is where it's stating, okay, I sold twice as many candy bars as popcorn. So I can take my popcorn, which is 25, multiply it by 2, and I find that I sold 50 candy bars. So in order to fit both constraints of this problem, where I sell twice as many candy bars as bags of popcorn, and at the prices they're set at, I made a profit of $175, I would sell 50 candy bars and 25 bags of popcorn.